Hello to you all, it's evening of the second day of Embedded World 2024 and I'm ending today's talks by speaking to Manuel Hollfelder, Senior Manager of Solutions and Application Synergies at Infineon, about a really fun product that Infineon have been working on. Manuel, thank you for joining us.
Thanks for having me.
First of all, what are you here to show us today?
Well, I'm here to show you the Infineon lighting shoe, which is, I would say, one of the world's first shoe that can actually hear its environment and react to it. So with nice and cool lighting effect. So here Infineon collaborated with the brand Adidas to use an Adidas Originals NMDS1 shoe to make it smart, to make it hear, and to make it also react to the surroundings.
Oh, excellent. Well, what was it like in terms of working with Adidas, a big company but not a tech company, and how did you manage your partnership in building this shoe?
So first of all, it was really exciting to work with Adidas because we are coming from two completely different industries, right? So a fashion brand and a tech brand like Infineon, and a fashion brand Adidas, of course. So we were all bringing together unique knowledge and unique ideas and a vision on the table, and we jointly co-created such a shoe. We were bringing our ideas, how does it need to look like, what effects do we want to see, how does it need to react, and this was really nice. And innovation is really at the core of Adidas, but also at the core of Infineon. And I think we built quite an innovative product, and we are really proud of it.
Oh yeah, well it looks great. I'm a size 10 by the way, if you have any.
I'll take a look.
Can you describe the key components of the Infineon Lightning Shoe hardware architecture, particularly PCBs and microcontrollers used?
Yes, definitely I can. So first of all, the shoe is following the sense, compute, actuate. So in this sense, of course, what you need then is, right, a microcontroller, you need sensors, but you need also something to power it so that it actually can actuate with the LEDs. So the components we selected were our best-in-class MEMS microphones, which are very robust, environmentally protected. We used our PSOC microcontroller in combination with an AROG Bluetooth low energy module. And of course, we used also our USB-C and barrel connector replacement solution for power delivery, so for charging and powering it. But of course, it's battery operated, so this is only used for charging. So as you see here, it really operates standalone. Then also, last but not least, what we have chosen are Optimus power semiconductors, so that we really have best-in-class efficiency, so that the shoe also lasts very long. Why and how we decided on those components, it's quite easy. As I said, sense, compute, actuate, but in a very efficient way, so that the shoe and the experience also lasts for a very long time.
Oh, excellent. Well, how do the embedded sensors in the Infineon Lightning Shoe work to enhance wearer experience, and what type of sensors have been embedded? I know you talked about some of the components there.
I talked already about some of the components, the key components. So how the sensors work are, first of all, they play and interplay with each other. So we have implemented sensor fusion as well, but how they work, actually from the bottom, if we have our microphones as set, and the microphone is able to detect tiniest noises. So the environment can really be recorded in a very nice way, so that based on this, the actual data can be processed by the microcontroller. And how it works all together is also with the interplay of other components, as I said already, like our power semiconductors. But as this is a concept shoe, of course has also integrated other features like a pressure sensor to also react on a pressure and altitude changes. So in the end, all of those sensors create this unique experience by sensor fusion and sensor data processing based on the PSOC microcontroller.
How fascinating. Well, what were the main challenges faced during the development of the PCB and microcontrollers for the shoe, and how were they overcome?
This is a very good question, because as you might think about it in a deeper way, a shoe is a very special setting, right, for hardware. So you have twisting, bending when you're walking. So this is not something I would say is stable environment. So first of all, what we did together with Adidas during this co-innovation, we analyzed, okay, what hardware do we need? Where do we need to put it? How do we need to assemble it? And how, although we need the flexibility, how can we make sure that we have stable connections between the different elements? So the biggest challenges really were to think about on system level, how can the engineering look like to bring all the components I mentioned earlier together so that they work in a reliable way in the shoe itself. And How were the microcontrollers selected? As I said, this is a concept shoe. So first of all, we decided the components also not only give us best-in-class performance, but also flexibility. So when we thought about the microcontroller, we thought that our P-Sub series is a perfect device and a perfect controller, because first of all, of course, it's low power, right? But it has very flexible peripherals and flexible components, so that you can even not only implement sound-based use cases. As an example, it also provides cap sense, which can also do capacitive sensing, which also opens many ideas, right? What else you can do when you put your foot inside the shoe.
Oh, fascinating. Could you explain the role of the software in the functionality of the shoe and how it integrates with the hardware components?
Very good question. So we have sense, compute, actuate, right? And software is really what brings the shoe to life. So as you see here right now, it's reacting to the environment, and it's also reacting to the noise level here. This is the demo mode I now switched on, and this is all enabled through software. On a breakdown level, software at the lowest level, as an example, is reading out the microphone, providing the drivers to get the sensor data from the microphone itself to the piece of microcontroller. Then on a higher level, of course, all the sound processing, right, filtering it, pre-processing it is also enabled through software. And if we go upwards, the architecture, even creating the lighting effects by analyzing the sound, by doing some analysis, controlling the LEDs, also deciding when to switch it off for power saving, when to switch it on, all the connectivity features. As an example, we have also Bluetooth, right? So you could also stream your music to the shoe, right? And also have your shoe reacting to the music you're actually listening, which is also a key feature. So all this is enabled through software, which is also at the heart of Infineon and which we provided for the shoe and for this microcontroller.
Oh, wow. What a shoe. Well, how does the shoe utilize its embedded sensors to adapt to the lighting effects based on the user's activity or environment?
So how does it react based on the environment is quite easy. So what we do really is based on the sound and the microphone. So we do the analysis of the sound data. And usually what we do are two things. We react based on the frequency, see here, right? And the music or the environment, but also to the sound pressure level. So actually how loud is it? And those two things combined then allow us to control the lighting effects in a way that they are influenced and controlled by the environment.
Oh, wow. Okay. Could you provide some insight into the design process for the microcontroller selection and the criteria that guided its choice for the shoe?
So, as I already said earlier, right, we started with this problem that it's quite flexible and that we have to make the right choice in terms of when combining all those elements on system level, that it works in a stable way. But as I also said earlier, when it came really to the microcontroller, for us it was really about flexibility. It was really about something to think, okay, today we put this microcontroller in a shoe, but of course the vision is, and I will also explain it later, if we select a microcontroller, right, it should not only have the right features to have it right now based on sound and controlling the light, it should really also enable, as an example, additional use cases like, imagine you also want to react to how you balance on the shoe, which could be enabled by cap sense. We have the pressure sensor, so when you move and change altitude, thanks to our highly precise sensed barometric pressure sensor, we can detect tiniest altitude changes of the shoe and also react to it. So the main selection of the components was, of course, to build cutting-edge technology into an everyday device, but also having the flexibility later on as a concept shoe to have it for development of new use cases, innovative digital use cases.
You talk about the selection criteria. I was wondering, how did Adidas influence the hardware design of the shoe, like in terms of aesthetic and, what
exactly
used?
So, first of all, Adidas provided the Adidas Original NMD S1 is a perfect format for this development, because how did they influence it was, on the one side we said, right, we want to build a fashion product, so it needs to look nice, it needs to leave an impression, right? So as we're digitalizing a shoe, it needs to be really something which is wow. So Adidas made the proposal to use this shoe because thanks to the thickness and where you can actually put the components, that you also have the nice openings for the lighting effects. This is really something which was strongly influenced by Adidas. I said earlier, the fashion brand, right? And then in this co-engineering, we thought about, okay, now we have the shoe model. What do we need to do to integrate the hardware? So we got feedback in the assembly process. How is it actually usually done? How can you glue, as an example, the flex PCB inside the shoe? Where can you make an opening to put the battery and the main board and our microcontroller? So this is all how we co-engineered it and how Adidas influenced the selection of the components.
Oh, interesting. Well, having Bluetooth LE for data processing and connectivity in the shoe, does this mean that we can see some on-shoe software products?
Definitely, yes. So of course, so as I said earlier already, right? So on the one side, Bluetooth enables you like many connectivity related use cases like streaming music or other nice features, but definitely you will see also software updates enabled through the connectivity inside the shoe.
Wow, fascinating. Well, what does the fact that sensors and a semiconductor normally hidden inside a smart IoT device is now in a shoe and fully functional tell us about Infineon or wider trends with chips and sensors?
So yeah, that's clear. So we at Infineon, we believe in digitalization and decarbonization, right? And this is a key example for digitalization. So we really believe that you can take any everyday device, even if it's dumped today, and through innovative semiconductor technology by Infineon, you can make it digital and smart. So we believe that something like this, although today this is only a concept, right, which gives the idea of putting it into a shoe. It's not mass market ready, but it gives the idea of what you can do if you put innovative semiconductor solution inside a shoe. So definitely the wider trend for us is thinking about more devices, more opportunities where you can turn today's dump devices into a smart technology of tomorrow.
Oh, wow. And can you discuss any specific software algorithms or processing techniques used to interpret the sensor data and control lighting effects in real time?
Yeah, so I already highlighted this a little bit earlier when I explained the role of software. So as I said, it's not a secret what we're doing. Basically, we have the sound data, right? And through Fourier analysis and also through calculating the sound pressure level, these are the two parameters we use to get information about what's actually happening in our environment. And then we use this parameter as an example if we detect several frequency bands of specific frequencies, or we see patterns in the sound pressure level change or the loudness change. Then we use this information to, in a very smart way, put it on the shoe. Because what you see here is really an LED light band which goes around the shoe. So in this sense, it is almost a digital display. So we then take this information about the sound in the environment and just based on this create the pattern for every LED, because every LED can be individually controlled. So based on the algorithm we are then using is just one example. If you have variations in the loudness, then what you can do is, as an example, change also the intensity of the light, right? And these are just some examples what you can do. But as this is a development platform, of course, taking this as an input for more advanced features, more advanced lighting effects, this is of course also the goal of the shoe.
Excellent. Well, and also, could you share any insights or anecdotes from the testing phase that highlight the robustness or unique capabilities of the Infineon Lightning shoe hardware?
So yeah, definitely, everyone when we started the development was thinking about, having the technology inside the shoe. Yes, that's definitely possible with our best-in-class products, very reliable, the highest quality. But there was a little bit of concern about, okay, what do we do with the battery, right? Because you're standing in the shoe, you're jumping, you're walking. How do you make it sure that it doesn't crack or that it doesn't get any problems? So we put a lot of thinking around what to do with the battery, how to protect it, etc. And in the beginning, it was quite a big concern, right? And we thought, hey, how to make it really robust? But thanks to this co-engineering, we came up with a very nice idea. So, which everyone immediately understood. We're putting the battery between two PCBs, rigid PCBs. So in a sandwich, like we call it our lighting shoe battery sandwich with our microcontroller and sensors. And this in the end made a very robust design, which everyone convinced. And I think this way from turning a fear into something very innovative, turning something into, okay, everyone understands and says, hey, no, nothing to worry about. It will work out. This is what I said also initially, right? Was the beauty of working together with Adidas and true co-innovation. It's this type of innovation thinking and circling around problems until you find a solution was really key of success for the whole project.
Excellent. And lastly, just generally, how does DigiKey help Infineon with your partnership with them?
Yeah, first of all, really great to have the partnership. How it really helps is to bring our solutions, our semiconductor components into the market, right, into the mass market, and really make sure that everyone out there who has the idea to build something smart has access to this semiconductor technology through DigiKey, and then eventually also is enabled to build the digital products of tomorrow, which eventually also help with decarbonization.
Excellent. Well, Manuel, thank you for visiting us today, and it's been fantastic to see this shoe and see what technology can do.
Thank you very much for the invitation.
Thank you.
Thanks.